Hello students, welcome to the third video for Chapter 8. We're going to look at crashing activities. So crashing activities means to shorten the project time by a specified number of weeks or number of time periods. So we're going to look at this basic example here. The examples for crashing cases or questions show two different times: the normal time and then what it could be crashed down to. So activity 1, in normal time, it takes 12 weeks. We could do this in 7 weeks. Shows a normal cost. If we follow the normal times, the project will cost, we can put a total in there. The project will cost $75,000. The project has a crash cost, which is the maximum, which is the cost associated with maxing or crashing the activity down to the maximum time. So if, for example, we crashed activity 1 from 12 weeks to 7 weeks, our extra costs incurred would be $2,000. So our total crash cost would be, or total cost for that activity would be $5,000 instead of $3,000. Extra information in this table that we would need is a total allowable crash time, which is just the difference between the normal time and the crash time. So we can fill out this right away. So we could crash activity 1 by 5 weeks, down from 12 down to 7. The crash cost per week is the difference in the crash cost and the normal cost divided by the total allowable crash time. And since we're talking about weeks, this would be a weekly cost. So activity 1 could be crashed, or if we crash it by 1 week, we will increase our project cost by $400. And we can copy and paste that down. So that shows the different crashing costs for the time period. Obviously, we want to minimize the extra costs. We want to find an activity or activities that we could crash that's going to minimize the extra costs we're going to pay. We know we're going to pay extra. We know we're going to pay extra if we want to shorten this project down from whatever time period it is down to whatever we need it to be. So there's various activities that we could shorten. We could look at shortening activity 6 because it has the lowest cost per week to shorten it. But if activity 6 is not on a critical path, shortening activity 6 is not going to do anything for us. So what we need, first of all, is to draw out the project in terms of its schedule and network, and then determine the total time as well as the critical path. So go back into our Jamboard here. We have our activities. We have the project management, project diagram here with the predecessors. The predecessors weren't listed on the spreadsheet that we were just reviewing, but we're going to use this one here. So the times that we will use is this normal time right in here. So activity 1 is going to take 12 weeks, activity 2, 8 weeks, and so forth. So if we draw this out, we get earliest times 0 and 12. 12, activity 2 takes 8 weeks. That's going to be 20. Activity 2, or activity 3, takes 4 weeks. So that's going to be 12 up to 16 weeks. Activity 4, the earliest it can start is after both activities 2 and 3 are finished. Activity 2 is finished at week 20, so the earliest activity 4 can start is week 20. And at week 4, or activity 4 takes 12 weeks as well, so this will be 32. Activity 5 must also wait until both activities 2 and 3 are completed. So the earliest they can start is after activity 2 at week 20. And that takes 4 weeks. That's 24. Activity 6 follows that, so it's activity 4 to 28. Activity 7, the earliest activity 7 can start is after activity 4 and 6. So it has to wait until activity 4 is completed. So activity 7 will start at 32 and go to week 36. So the time, project time, is 36 weeks. Now we can chart this out in blue for the critical path. We know how to do this. Now, based on the other videos, I'm just going to list this out here so we have an idea of what the critical path, what the critical path is. 20 and 17 and 12 and 0. So the critical path will be activity 1, activity 2, activity 5, and, oops, not 5. Activity 4. And then activity 7. Activity 1, 2, 4, and 7. So we go back to our spreadsheet that lists out all the activities. And we know that activity 1 and 2 are on the critical pathway, and activity 4 and activity 7. So if we want to shorten the project time, we start at the activities that are on the critical path. So we look at activities 1, 2, 4, and 7. We're going to definitely not pick activities 4 and 7 because they're going to add $7,000 per week. We're going to start right there at activity 1. It only costs us $400 per week. We can shorten it by 5 weeks. So let's shorten it by its max. We're going to shorten this from 12 down to 7. So what I would do is basically go on to a new chart, and activity 1 now has a time period of 7 weeks instead of 12. And we'll see what kind of change that makes. So original time was 36 weeks. We want to see if we can shorten it down by 5 weeks to week 31. Activity 2 starts at 7, goes to 50 now. 7, that's going to go up to 11. Just looking at the normal times here, activity 4 has to wait until activity 2 is finished because it's the longest activity, and that's going to go 12. Activity 5 also has to wait until activity 2 is finished because activity 3 is already finished by that time. 5 takes 4 weeks, that's 19. Activity 6 after activity 5 takes 4 weeks, that's 23. Activity 7 has to start after activity 4 and 6 are completed, so it has to wait until activity 4, 7, and it takes 4 weeks, that's 31. So the time now is 31 weeks. The original time was 36 weeks, so we have shortened the whole project by 5 weeks. Let's just see if the critical path has changed, because this is something you'd have to do if we wanted to shorten it down by more than 5 weeks. Every time we shorten activity, the critical path may change. And the key is we're only going to really shorten the project time if we shorten activity on that critical path. So let's look backwards here. 31, 27, 27, 23. This would be 27, 15, 19. So it looks like activity 2 has to finish in enough time for activity 4 to start. So this is going to be 15 here, which makes that 7. Same thing with activity 3, 15. That's going to be 11. And activity 1, 7 and 0. So the critical path is still the same. It hasn't changed. But the extra cost to the project is 5 weeks times $400 per week, or $2,000. So the extra cost is $2,000. So the project cost, instead of being $75,000, it's now $77,000. We can look back at our spreadsheet for that. There's the total time before we crashed anything. We've added $400 per week times 5 weeks, or $2,000. So we're adding basically the difference there to the project time.